Welcome to our class. In this video, we are going to learn about the trigonometric ratios of special angles. The special angles are 0, 30, 45, 60, and 90 degrees. But in this video, we are only going to derive the trigonometric ratio of 30, 45, and 60 degrees. Let's start with a square. What can be said about its sides? Right, they are congruent. What can be said about its angles? Yes, they are congruent and they all measure 90 degrees. What can be said about a diagonal of a square? Yes, the diagonal of a square bisect opposite angles. What figures are formed by a diagonal of a square? Exactly, two congruent triangles. Now, let's focus on one triangle only. What kind of triangle is this? Perfect. It's a right triangle since one of its angle measures 90 degrees. What then is the measurement of the two acute angles? That's right, each of the acute angles measure 45 degrees, as we have established a while ago that a diagonal bisect opposite angles. If this side or leg measure 1, what is the measurement of the other leg? Absolutely, it's also 1 since these two legs are the sides of the square it came from. Now, use the Pythagorean theorem to solve for the length of the hypotenuse. Did you get square root of 2? That's perfect. Now, we are set to compute for the trigonometric ratios of special angle 45 degrees. Though we may use any of the 45-degree angle, for easier process, we'll stick with this one. So, first, the sine function. We know that the sine of an angle is equal to its opposite over hypotenuse. Hence, sine 45 is equal to 1 over square root of 2. Rationalizing that by multiplying the numerator and the denominator with square root of 2, we get square root of 2 over 2. So now, we know that sine 45 is square root of 2 over 2. Let's move to the cosine of 45 degrees. Cosine is the ratio of the adjacent to the hypotenuse. So, cosine 45 is equal to 1 over square root of 2. Applying the same process with the sine, which is rationalization, we get cosine 45 is equal to square root of 2 over 2. Finally, let's solve for the tangent of 45. The ratio for tangent is opposite over adjacent. Using that, we'll get tangent 45 is equal to 1 over 1 or simply 1. So, tangent 45 is 1. Now, let's move to getting the trigonometric ratio of 30 degrees and 90 degrees. We'll start with an equilateral and equiangular triangle. What does equilateral triangle mean? Exactly, a triangle with 3 equal sides. How about equiangular? That is true. A triangle with 3 equal angles. So if one side measures 2, what is the measure of the two other side? Correct, they would also measure 2. If this triangle has 3 congruent angles, what is the measurement of each angle then? Right, 60 degrees. Now, let's divide this triangle into 2 equal parts. What kind of triangles were formed? That's right. 2 right triangles were formed since there will be right angles here. If this side measures 2, what would be the measure of this side? Yes, it would measure 1, because the original side had been halved. Using the Pythagorean theorem, what would be the length of this side? Perfect, square root of 3. Now, let's focus on the angles. It's been established that this is a right angle, and this one measures 60 degrees. What would be the measure of this angle? You're right, it would be 30 degrees, which is half of 60. Now, we are set to calculate for the trigonometric ratios of 30 and 60 degrees. Let's proceed with the 30 degree first. The sine of 30 would be 1 over 2, or simple 1/2. Next, the cosine of 30 would be square root of 3 divided by 2. And lastly, the tangent of 30 would be 1 over square of 3, which is equivalent to square root of 3 over 3. Now, try to complete the table by computing for the trigonometric ratios of sine, cosine, and tangent of 60 degrees. Pause the video for a while and complete the table. Here's the completed table. Did you get the same answer? That's great. We did it. We now know the trigonometric ratios of the special angles 30, 45, and 60 degrees. In the next video, we are going to learn about angles of elevation and depression.